Programming Throwdown, Episode 96, Continuous Integration with Rob Zuber. Take it away, Jason.
Hey everybody, I'm here with Rob Zuber, CTO of Circle CI, and we're going to be talking all about continuous integration, and that might be a term not a lot of people are familiar with, but we have a world-renowned expert here who's going to explain it in detail. So why don't you tell us, before we jump into continuous integration and testing and all of that, tell us sort of what kind of led you down this road, what's sort of your background, and how did you end up CTO of Circle CI?
Yeah, I'll try to make that a short story. I've been in the industry quite a while, so a few different points that I would make along the trail. So I grew up in Toronto. I went to school at a college called Queen's University and studied engineering physics. Graduated, went into manufacturing of all things, was working on computers stuff, and then some friends of mine started a company in the late 90s, the original dot-com boom, and they said, hey, we need more people. Literally, like, nobody really, that wasn't a known thing at the time, and so anybody they knew that they thought they could convince to come and work for nothing, they were interested in. So that was basically that's how I got into software. I just showed up and they were totally tolerant of my ignorance because I just needed to learn some things, and they just needed, they needed people.
Give you, I've heard crazy stories about the dot-com era. I mean, did they give you like a Porsche on your first day or something like that?
I think that's dot-com California. Dot-com Toronto was much more reserved. We were like one of two startups in the city or something like that back then. Right. And in fact, so that company was eventually acquired by a company down here in the Bay Area, which is why I ended up moving. So now I live in the Bay Area. I've been here since 2000 when we were acquired. But I didn't really start out doing software as a result. I was more, at the time, I ran a team that we called systems engineering. I think 4 iterations later, we'd call that SRE, something along those lines. I spent a lot of time in data centers. I think most people don't know what a data center is anymore because they just let AWS and Google do that for them. But
yeah, actually, I'd love to hear a description of a data center. I've actually never been in one. I mean, it's just like this ephemeral thing to me.
Well, ironic, given that I'm getting over a cold right now. The one thing I can tell you about a data center is I've never gone into one and not gotten sick.
Really?
Because I would always find myself standing next to, 2 things would happen. One, it was usually under some kind of great stress, like all-nighters, whatever, because we were trying to roll something out or do some huge migration and deploy a new data center. We'd fly down to usually somewhere in Virginia, kind of like US East 1 is in Virginia. I think that's probably built of all the old data centers that we used to use.
Yeah.
And you'd spend days straight in a cage full of computers that are really hot. And so on one side, you have all this heat pouring out at you, and on the other side, the air conditioning is coming in trying to cool, or it was just like forced air cooling systems. And your body, at least for me, my body was always just like, what are you doing to me right now? I haven't slept, I haven't eaten, and on one side I'm freezing cold, and on the other side I'm boiling hot, and invariably, and it's like recycled air and all this stuff.
Yeah, so someone explained this to me. There's a gentleman that I work with, and he said, and correct me if I'm getting this messed up, but the individual machines, so the data center, they don't go to Best Buy to buy machines. I mean, it's like they have so many that they're all custom, and the machines don't have fans, and that's because they design the entire data center is basically one giant fan. It's just air is moving across the machines, and so they don't need their own fans.
Yeah, well, again, I also am someone who just buys machines from AWS and Google and whatever now. So a lot has changed. Like we were buying sort of 1U, 2U, a U is a rack unit, but like thin pizza box type machines at the time. And they would have had individual cooling.
Oh, okay, got it.
Now you tend to buy more blades, and that's been a thing for a long time. So you buy a chassis, and each actual computer is just like a card that you slot in, and then it has something in it called a backplane. Or I think it's a mid-plane, backplane, doesn't matter. And they slot into that to get power and cooling and stuff like that. And also now I think a lot of data centers use liquid cooling even. So there's, because you get This is one thing I might remember from my engineering physics degree, but like you get better thermal transfer, right, through like solid contact than just air blowing over.
Yeah.
So if they can cool the chassis and whatever, like transfer that in. Of course, I don't know if you've ever seen a heat sink on top of a chip, but those are designed for air cooling, right? You can't like blow liquid over the heat sink, but so I don't know exactly all the details of how this stuff is built. They've done a lot to cool. I mean, power. I was actually looking at this because we run a lot of compute at Circle CI. We'll get to that later. And so we've actually looked at, like, are we at the point where we need to own some of our own hardware? And we do for some very small specific cases. And as I started to look at how do you even do data centers these days, there are some where the model is just you pay for power because, providing power and providing cooling is what really matters in there. Like they don't care how much space you're using, they care how much power you're drawing, right? Because like that's where the real sort of expense is going.
Yeah, that makes sense. It's usually way out in the middle of nowhere, like Iowa or something. So yeah, space is not an issue.
Right. Exactly. So yeah, I did a lot of that at the time. I was doing, I was kind of a DBA and like focusing on actually build systems. Interestingly enough, first thing I did when I showed up was write a build script and figure out how we're going to get our code into production as quickly as possible, even in 98 or whatever year that was.
Wow.
So we were acquired and moved to San Francisco, did a bunch of different things at the acquiring company, including some product management, some sort of like prototyping and like strategy work and things like that. Honestly, some sales type stuff, like going to visit customers and help close big deals by helping them understand our technology. And only sort of, I think 2007, I finally left there and went to a company actually as a CTO. And ironically, at that point, really spent my days writing software. Because at a tiny company, that's what you do as a CTO, right? Like you're a CTO in name, but you're kind of a team lead and you're just, the most senior engineer working on building the product.
Yeah, that makes sense.
Because it was like a 10-person company, right?
So was that sort of a kind of a shock because you had probably done less and less coding over time? As you say, you've been doing sales and you've been trying to sort of run that larger company. And then now you end up as CTO of, let's say, I don't know, 3-5 person company, and so you have to get back on the saddle, right? Was it sort of hard to ride that bike again?
Well, what's interesting is honestly, like I have a pretty unusual career path. I would say that was when I first started writing software.
Oh, that's true.
So
okay.
I basically, up until that point, I had done a bunch of sort of like prototyping and things like that, but like sitting down and writing production software every day as my job. That was the first time that I really did that because I was always this jack of all trades, pulling things together, building a prototype and then flying to a customer and selling it for crazy amounts of money and then handing it off to an engineering team to say, okay, make this real, that's good living, by the way, if you can do that.
That sounds really awesome. I mean, it sounds also like a huge responsibility. I had a similar issue where one of the sales engineers, we had this system and it was an embedded system. So think of like a robot, right? Mm-hmm. And they wanted to do some more complicated AI in this robot. And the sales engineer said, oh, it's fine. We could just run it at 30 hertz instead of 60 hertz. And so that's just ridiculous. Like it's like the entire robot, all the sensors, everything had been designed to run at 60 hertz. But he's like, oh, no, don't worry about it. Like, it's just sort of like, we'll fix it in post. And all of us engineers, when we heard that, we were like, what are we going to do? I mean, and so you have this situation where you could potentially build a prototype. You really have to know like what's actually possible, in the back end, right?
Yeah.
You have to have a good relationship with your eng team.
Yes, exactly. And I feel like I'm making it sound a little worse than it was because I did have that relationship with the engineering team. Like I knew our code bases really, really well. When I built prototypes, I built them using our production code, like modifying our production code to do certain things, just did them very quickly and said, look, I know this isn't what we would want to ship to a customer, but we were able to get, the business. It was sort of like what you would now call an MVP maybe versus a
right.
Although, well, you could go either way because honestly, you wanted to throw a chunk of it out and do it well. But interestingly, in so doing, because I was deep in our real code, and there were some engineers there, the likes like the capability of which I probably haven't seen since, or have seen rarely since. I learned a lot just by working with their code, by really being deep in sort of how they had built systems and spending the time. And it was kind of a weird because I couldn't get a lot of their time. I couldn't say, hey, come sit with me and explain to me how this works. So I just studied. It was like reading very large volumes of code as a means to understand how good code could be structured. But it definitely influenced the way that I thought about software for a long time after that.
Yeah,
although it was primarily C, which I don't do a lot of anymore.
Yeah, right.
So then I went and did this, took this role as a CTO. It didn't really work out that well. I was there a couple years. The company, couldn't really find traction. And then I started a couple of my own things, did some consulting. And then 2011, I started a business with two other guys, a guy by the name of Jonathan Ehrlich and another gentleman, Jim Rose. And we worked on that business for a couple years, I think 2011 to kind of late 2013. We built a marketplace. It was a cool experience. We raised some money. We built out a team, but things changed in the market. It didn't work out. We then tried to find some mobile first, because now it's late 2013. We tried to find some mobile first approaches to the problem we were trying to solve. And then once we had the pieces and some mobile expertise, we just started spinning out mobile apps. Like, maybe people will like this, maybe they'll like this, totally unrelated to each other. And then we said, wow, building iOS apps is really hard. Like the tooling is not very good. People don't really understand how to test in this world. I would say Rails developers were just starting to make the shift into iOS because it was becoming a thing.
Yep.
And the shock of a bunch of Rails developers who were like test-driven development, you skeleton out specs immediately, showing up in iOS and just saying, has anyone ever written a test?
Yeah, right.
And then if you actually look at, I don't know what it's like now because I haven't done iOS development in a while, but if you look at the 2013, 2014 tooling, it's all written in Ruby. All of the test frameworks, all of the drivers, it's because it was this shift of people who were coming over that world, and they just went, what is happening here? Yeah. And they weren't about to write a bunch of desktop tooling in Objective-C because that just seemed like a lot of work. So they created all these frameworks in Ruby, and you can kind of see that history. Right? It's like a little archaeology for you.
Yeah, that's interesting. So at 2011, you started as CTO, right? Of the first, and so now it's 2017, and
this is 2013, 14.
Oh, 13, 14. Okay, for the iOS era, right?
Yeah.
And so that's 3 years. And so what is, I think that a lot of people out there would have given up, like would have said, okay, this didn't work out. Maybe they would have given up even much sooner, right? And and you persevered, which is which is to your credit, right? So what sort of what was keeping you going on that track? Even 2, 3, 4 years.
A couple things. We so in that company we got through a seed round and an A round. So we had money to run. We had investors who believed in us, but then we saw the market change very significantly. So we were building a marketplace, but we were trying to find the intersection of the marketplace and social. We were leveraging the Facebook platform to try to build and grow. And Facebook around that time, if you go back and look at where they were headed, made a big shift away from platform and into mobile themselves, actually. And that really took away, like, they changed algorithms about how things went into the feed. There was a ticker for a while there, and then it was gone. And so the avenues, which, if I'm honest, we were basically spamming to drive growth, sort of dried up, and our ability to try to get the flywheel going and get to scale disappeared. So we we wound down a chunk of the company. We gave some money back to investors. But honestly, at that point, the thing that kept us going is people, right? Like, for me anyway. So by the time we got to the point, as we head into 2014, where by the time we got into the beginning of 2014, there were basically three of us: myself, Jim, who I had mentioned, and then one other engineer who had been one of our early engineers. And we had realized, hey, this tooling is really hard to build these mobile apps. And so we decided to build a CI/CD platform for iOS and for mobile.
Yeah, that makes sense. So I think it's like, yeah, if you have the, talented folks and you have camaraderie, you trust each other, you're willing to, sacrifice. I mean, I saw a situation where they actually had, in my opinion, a successful startup, but that person got, I don't know really what the phrase is, not quite cold feet isn't the right word, but they ended up kind of bailing and joining, kind of a big company. And that kind of put the startup in a bad position, right? Mm-hmm. So in your case, if you have a good core group of people, even if, as you said, the market changed in a way that you couldn't control, and so that initial idea, you just couldn't save it. No amount of talent could save it. But now you could potentially even have stronger camaraderie than you did going into it, because you built something together that you could be proud of, even if you weren't able to pull it off, in the marketplace, the broader marketplace, right? And so that kind of led to this realization that there's this other market here that we could tackle.
Yeah, absolutely. And I would say from some experiences prior to that, both when I was working in larger organizations, when I joined a startup, in other startups, my understanding of the value of the people versus the idea, the business, whatever else, had just grown and grown. And so recognizing that I was working with a couple folks who we worked really, really well together, that was of huge value. I was willing to take that and go sort out what it was we were going to do over, go work at some large organization or whatever. And I mean, you fast forward to today. So Jim, from that story, we built Distiller. We got acquired into Circle CI with that iOS CI/CD capability. And Jim is the CEO of Circle CI, and I'm the CTO. So we continue to work together since we started in the beginning of 2011, right? And that's so finding that honestly is huge. And as I look at, to your point of other startups where people kind of fall out, there's a lot of startups that have great ideas and are having success, but the tension between the founders, between high-level people, breaks things apart. And so finding great working relationships is huge. And so sticking with that when you find it, I would say is a big part of, to the question of what kept us going. It was that, just like, hey, we really like working together. We know that we're able to solve big problems. Let's just pick a big problem and go solve it. Yeah,
that totally makes sense. I think for folks out there who are, maybe they're not necessarily starting a company, but maybe they're doing some side projects, I think a great piece of advice, that's actually something we've never said on the show before, is to grab a buddy, like get someone else. And maybe if that person has a different cool idea, you both implement both of them, right? At least that way you have another pair of eyes, and you can kind of go on the journey with someone else.
Yeah, totally. And I mean, that journey, like as someone who's done, the both ends of the spectrum, I guess I would just say it can be pretty challenging. There's a lot of great press given to the huge organizations that succeed, these overnight successes that are honestly 10 years into their process or whatever.
Yeah, right.
But there are some pretty dark times in there. And if you want to get through them and you want to get through them effectively, like having people around you who, support you and you work well together and all those things, that's a huge difference. I can't even imagine trying to go it alone, honestly.
Yeah, that totally makes sense. And so you saw this need to, I mean, I remember early iOS development and Android development, and basically they provided this emulator, and even that wasn't very good. It was very slow, and they're basically like, look, you if you want to test this, run it on a device until it stops working. That was kind of their philosophy. And you saw, you kind of had with your experience, you kind of said, no, I think people are not gonna put up with that. there's got to be something better.
Yeah, exactly. I mean, we in the process again of trying to build some apps ourselves, we just thought this doesn't seem right. That people don't have this capability. And we had been using CI and CD for like the business before was actually a Rails app, and so we were CI/CD centric. We were using that as a core part of our process in building. And as we switched to mobile, we just thought, well, this doesn't seem like a great environment. And especially, I actually don't know what it's like now, but at the time we would spend 2-3 weeks getting a build approved through the App Store and out into the hands of customers, right? So when you do that and then there's a problem, like you finding out because the second customer that tries to use it runs into an issue, and then spending another 3 weeks trying to get the patch out or whatever. I mean, there was a expedite process, but it would still take time.
Yep.
Now I'm back in pretty much cloud world where, if there's an issue, we just patch it and release the patch and it rolls out immediately and, almost doesn't matter. But in that space, in the space of, it's going to take me 2 weeks to get the fix out, being really confident in your delivery has an even higher amount of value for you.
Yep, that's right. And a lot of these apps, there's so much competition in the App Store. And there's so many people doing SEO on the App Store that if your app has a bug in it, someone else will realize your app has an issue, probably write a similar app. I mean, depending on how much lock-in you have, but write a similar app and just take away your entire business. I mean, I've seen it happen a lot in the games space where it's just you can't patent a game. There's not much intellectual property there unless it's some trademark like a movie or something. And so, I mean, it's just one mistake, you can get wiped out. And it's the ecosystem that didn't have very good testing. So it's kind of like, it's almost the opposite of what you described earlier, where the market sort of closed. This was a case where you were coming in with a lot of experience and a market that was just exploding. And mobile is still getting bigger. I mean, there's a huge expansion in India and in other countries on mobile.
Yeah. And I would say we continue to see that. I mean, so mobile has been exploding, but also, now within Circle CI. So we did that for 4 months, 5 months, basically, before we joined Circle CI, because we saw this is a bigger thing than just mobile. But now, having been at Circle CI over 5 years, I continue to see this space of investing in developers, enabling them to be really successful, delivering quickly, getting their ideas into the market, and this whole software is eating the world. How can we enable our software teams to really drive competitive differentiation for us? We're just watching that blow up, right? And so we're in the middle of that, which is a very cool place to be. But having been through, having been around in the kind of early 2000s where everyone said, wow, software development's really expensive. Let's go find the cheapest possible people to build software. Let's manage it like a cost center, to go 180 degrees to software is how we're going to differentiate as a company. How do we invest as much as possible to build the best possible software with the greatest people is, I will say, as a software developer, very rewarding to watch as a cycle in the market.
Yeah, definitely. So this is one of these, or I guess many products have this where, your target audience, so there are going to be people who already do a ton of TDD, a ton of test-driven development. And in a sense, now you're dealing with this incumbent. So maybe they have some homegrown thing, whatever they're using, right? Then you have all the way on the other end of the spectrum where, I mean, I still know of folks who don't write any tests, who are have some pretty significant responsibility, right? So if someone comes to you and says, like I'm doing this FPGA on this robot, or I'm doing something very specific, like why should I write tests, right? So what would be kind of your response to that?
Well, I mean, that's an interesting question. I think about testing in general, and then in the specific cases. I have I guess a long history with testing. I mean, actually, when I all the way back to when I started out and did systems engineering and stuff like that, I also ran a QA team, and we thought about testing very differently back then, right? It was sort of we'll write the code and then we'll give it to some other team and they'll click on buttons and sort of move through all of the capabilities, and then eventually we'll ship. And it was, is the bug count converging as we get closer to our release day? I mean, it was a very, very different time. Right?
Yeah, I remember those times a little bit. Yeah.
And ultimately, for me, it's about coming from those days. Like if you look at that's a long arc of evolution in software development, but it's really about feedback loops, right? Number one. So as an engineer, like we've tried to reduce all of the stages, right? We've gone from waterfall to agile, so that we're working in shorter increments, and then all the way to the point where we're testing small bits, and then we're putting small bits out in front of customers. And what I value in that is that I still have the context loaded in my head, right? So in the absolute ideal, maybe we'll come back to this later, continuous deployment, right?
Mm-hmm.
My customers are seeing something that I just wrote, which is great. It's fulfilling because I just wrote it and now I'm delivering value to the business. But also, if something goes wrong with it, I just wrote it, right? When I have those moments where I write something and I put it in production and something, goes wrong or whatever, because there's different data, things that I didn't account for, my reaction, I find usually under those circumstances is, oh, right, of course. Of course I didn't think of that thing, and now I know exactly where to go and fix it.
Yep.
And if I deploy that code 6 months from now and someone says, hey, this thing is happening in production, we'll just be like, is that something I did? Is it something someone else did? I don't know. Let's go spend 3 days sort of trying to figure out where the bug might be. Do that. We'll do some Git blame for 6 months and try to figure out where this happened.
Yeah, bisect thousands and thousands of commits.
Exactly. And so I think of testing, one key point behind testing is just pulling that in even more, right? So I'm writing code, and I'm not a zealot when it comes to test-driven development. I'm going to write a test for everything. There's absolutely cases where I say, oh, okay, I totally understand what this needs to do. I think it's going to be a little tricky to get it right. I'm going to write a test, and then I'm just going to iterate on this thing until I get it right. Okay?
Yep.
There are other times where the testing is awkward or weird, and it just feels like I'm cementing my idea before I get there. I mean, there's lots of arguments on both sides of that. But either way, the ability to just validate as I'm working that my ideas are correct, I think is one
that makes sense.
Really good reason to test.
In a way, it's a customer before the customer, right? So,
right.
And
I would say with that, it's a customer in two different ways. So one, I'm getting that feedback right away. So again, it's totally fresh. If I write a bug and I catch it immediately, it's not even annoying. It's just like, oh, okay, yeah, that happened. I will fix it and I move on, as opposed to, again, the day or week or month later.
Yep.
But also, you become the first consumer of your API, right, or your design, as you're writing tests for it. So you say, okay, I need to test this thing, and here's how I would pass data into it, and here's how I'd pass or get data out of it. And this feels really clunky. Maybe my design isn't actually that good, right? Maybe I'll think a little bit differently about
makes sense.
how I'm structuring my code, and the kind of being that first consumer of it. I think that's really evident when you're building a library or an API or something like that, like an actual published API. But all software, to some degree, as you're building up layers, is an API to the next layer, right? So, or an API for the next layer, if you will. And so, having that point of reflection, I think is really valuable. But like, it's interesting because having done it for so long, I mean, all the way up to continuous integration, continuous deployment, I struggle to project myself back into the world where I didn't have tests, or I didn't have continuous integration, continuous deployment, and even imagine what that was like. Because I was talking to someone recently where we were talking about this is a really good example, going back and working on something that I haven't touched in a while.
Yeah.
And having the suite of tests that basically says, if I change this in a breaking way, or I break something else by trying to fix whatever it is that I'm trying to fix right now, that'll be really clear, right? If you go back to a code base that doesn't have any tests around it, and you think, okay, now I need to understand every single facet of how this code interacts so that I know that if I make this change, it's going to be safe. That's a really uncomfortable situation, right?
Yep. And if someone... if for everyone out there who's had that experience, That's how everyone who looks at your code sees, right? So if you come to your code a year later and you have that agoraphobia and you just say, oh, well, forget it, it's done, I just need to delete this because I don't know what I'm doing. That everyone who comes and visits your GitHub page, that's how they're going to feel too.
Yeah, it's absolutely true. Like, I think we think of the consumers or the readers of our code often in terms of other people, and forget about us in a week or a month. Like, I might be the maintainer of this code, but I have a lot of other things going on, right? I'm going to go work on a different project in a different part of the code base, and then come back and say, what was it I was trying to do here? I mean, there's lots of outside of tests. There's, naming and and structure and good abstractions and clear boundaries and commenting. There's a million other ways to make that better.
Yep. And the tests help with that. I think, maybe your first test can only be, test main, and it just runs your whole program. And then you find that, okay, I need to wait 3 hours to know if my test passed or not. Maybe I need to factorize this down. And, now I factorized it down, but now I need a simulated clock because I was using the system clock and that only worked when I ran the whole thing, right? And so eventually when you're done with that exercise, you'll have much better quality code.
Right. And I think that the small increments, I mean, to your point, coming from the other way, having the units, right? Talking about unit testing as kind of a lowest level, breaking those apart, being able to reason about the work they do, and then composing them together into higher levels of output or abstraction, higher levels of abstraction, is a very good design practice, right? Yep. And so using tests as a validation that you're doing that effectively, I think is nice. I use this expression, and I think it actually just comes from my manufacturing days. I don't know if people actually talk in this way, but when I was manufacturing, we were building circuit boards basically, and we helped our customers with what we called design for testability. And so we would relay out the circuit boards in a way that the probes that came, we basically had electrical unit testing, right? You could put probes on the board and test a sub-circuit of the overall circuit to say it's working effectively, all the solder joints are good, like that sort of thing.
Yep.
And it's easy to think about it in that physical sense, or at least it is for me because I was there, that, you need to be able to fit a probe and you need to be able to break up this part of the circuit in a way that allows you to not have, electrical bleed into other parts and stuff like that. And I think that really carries into how we build software. And I think if you design in a way that's more testable, you actually design better software. I mean, there are weird edge cases for sure, but when you think about isolating out business logic from inputs and outputs, right? So if I have some patterns that talk about this, like ports and adapters or hexagonal architecture, these sorts of things, the core is meant to be pure business logic. And that is a much more testable unit than if the core knows about the database and about the web server and the format of data coming in, right? So if you push serialization and deserialization out to the boundaries and focus the entire core of your application, your system, whatever it is, to business logic, then you can just hand it, manufactured data instead of, okay, I got to write all this stuff into a database and then send this thing over the wire, through the web. And then it becomes this really complex way to try to build out your tests. And you end up back in that place where you basically run main and check the output at the end and say, I don't know, did I get the right result, right?
Yeah, exactly. Yeah, I think, now there's the hot swapping feature. So for people doing web development, and I think that could be a crutch that people could lean on a little too much, saying, okay, Firefox is going to be my testing tool, right? Mm-hmm. And then the issue there is now you're limited by your own time, whereas what you want to do is use the computer's time, and so you could run 1,000 tests on the computer, and even if they do take a long time, you could go and do something else while it's off doing that.
Honestly, if you're testing units and functions and stuff like that, they will not take a long time. Computers, it turns out, are really fast.
Yeah.
They're very good at doing things in parallel. Computers have a lot going for them that we as humans don't, right? And and honestly, it's tedious as a human, right? Especially if I'm a software developer and what I like doing is writing software. Why would I not want to write more software to do the thing that I find really tedious?
Yep.
And just repeatability, right? Like you can say, oh, I'm going to test this case and this case and this case and this case. But if you ask me to just say, does login work? I'm going to put in my username and password. I'm going to log in and say, yep, I logged in, therefore it's good. But I didn't put the broken password or like the weird spaces or, the disabled user, like all of the, conditions that end up being real conditions in your software. It's hard to reason about those, right? And then to go through them all. Yep. So for me, it's just repeatability, confidence, all of that, and feedback, fast feedback to allow me to just keep going and build the things I'm trying to build.
Hey guys, I'm going to interrupt you for a second because we actually have some sponsor information to talk about. We have partnered up with Educative.io to talk about an awesome set of classes that they offer for learning all kinds of topics in programming, everything from beginner things to more advanced things like embedded programming. I know, Jason, you looked at some machine learning ones.
Yeah, the machine learning course was awesome.
They have all sorts of things related to programming, and it's a pretty cool setup. A lot of times you are needing to do your education in a place that may be noisy or loud. And so what Educative has done is all of their courses are text-based and in interactive notebooks. So you read the material and you can do it pretty much anywhere because you don't need to put on headphones or anything that would distract you from the rest of your environment. So you're pretty much just reading. But better than a textbook, it's interactive. And so you can actually complete the examples and work on the projects as you're going through.
Yeah, if you're like a kinesthetic learner and you're the type of person that like needs to sort of do things to really absorb stuff, this is perfect because you actually have to go through and run the examples yourself and make changes and improvements.
Yeah, I wouldn't have known the word kinesthetic. So thanks to Jason for giving it the technical name, keeping it real here. They actually were pointing out that Jason and I are no longer students, unfortunately, but a lot of you guys are. And we've mentioned in the past before the GitHub Student Developer Pack, which is something you can sign up for as a student and includes all sorts of things from a ton of great companies. And Educative is one of those companies. And so if you're a student, check them out through that package. And if you're not, they have actually agreed to give us a discount code for all of our listeners. If you go to educative.io/programming throwdown, I said that pretty fast, but we'll have it in the show notes as well.
Yep, I'll put it in the notes.
20%. Yeah, we can get 20% off of any course. So Jason, so you said you did the machine learning course. Tell us a little bit about what was it like doing that course?
Yeah, I thought this was slick. So basically, they kind of walk you through the basics of doing some data science, handling some data frames, and they walk you through training a model. Again, the part I really love is the interactive part. So if you've ever seen Mathematica Notebook, we had Steve Wolfram on the show, so hopefully some of you folks check that out. Or if you've ever played with IPython Notebook or Jupyter or any of these technologies, you kind of know what it's like to kind of get that instant feedback. It's actually really gratifying. And this is similar where it shows some formula. You could go in and tweak it. You could see sort of how you can break it, how you can make it better. And it kind of gets you in that sort of test, retest kind of mindset, which is super exciting. They also have a set of from scratch courses that I briefly looked at. And these are awesome. They basically take you from almost zero knowledge all the way to kind of writing your first programs and being a developer, right? So, I mean, I remember when I started, when I was in grade school, and without knowing basic things like ls, right, or find, or just things like that, it's actually really hard to get started. You start saying, okay, I have these two files, I need to merge them. Let me write a C program, right? And so what this does, it kind of walks you through. It says, okay, let's wipe the slate clean and start from scratch. Here's a list of kind of really good utilities, and it gets you up to speed really quickly.
Yeah, they have a variety of languages: JavaScript, Java, C++, Rust, Scala. They're kind of all over the place and covering a wide variety of things. So it's not just limited to a lot of the tutorials today seem to be Python, and I know Jason's a big Python guy. I'm not. So it always feels a little bit sad when I go to click on some interesting programming topic and they're kind of doing it in Python. just because sometimes it's a little hard for me, at least, to kind of apply that to the work that I do. And once you kind of are well established and know something, you can poke around at internet tutorials and pick up a gem or two. But having a curated course that goes, through a sort of well thought through syllabus and teaches you stuff in an order that makes sense is enormously helpful for actually learning the material and not just pretending like you're learning the material. And so I really appreciate that about being able to have actual courses.
Yeah, totally. So the URL one more time is educative.io/programming throwdown. It's case insensitive. You can type it however you like it. We'll also give a link in the show notes that you can check out.
All right. Well, I think it's time to go back to the interview. Thank you to Educative, sponsor for today's episode.
So what is the point then of continuous integration? What someone might say, well, I can just run my tests before I git push.
Yeah, so I think it's easier to reason about continuous integration as you think about larger and larger teams, because it really is that point of integration, right? And so I know for some of your audience, probably working in a large team on a shared code base is not necessarily what they're doing all the time. But for people who've worked in large teams, you absolutely can conceive of the conflicts that arise as people work on similar parts of the code base, or maybe change a piece of code, a class, a function, whatever, that they don't realize is being used somewhere else.
Yep.
And so learning about those conflicts after long periods of work, and it's interesting, our definitions of long periods of work have changed over the time that I've been in software, but I've seen projects where entirely different teams fork something, work on it for 6 months, and then try to merge their changes back together. I mean, there goes another 6 months. Right?
Yeah, that's right.
And so merging them together, daily, less than daily, just saying, oh, okay, we made this change, let's merge it in, gives you the opportunity to identify any conflicts as they start to arise. They usually tend to be quite small, but what you're doing is effectively taking those two sets of changes, bringing them together, which is a system or is a view of the code base that neither of those individuals had, right? Bringing those two sets of changes together and then running the set of tests on that, right? And then assuming that all works, or I guess whatever, it's happening on branches, but then giving you the opportunity to bring them together, and then, continuing to build on that, right? So people are making small changes to the code base, and bringing them together, and then that in Git, probably master, but your default branch, whatever it might be called, trunk, is constantly in a state where you know it to be good, right? And in an ideal world, you get to what we would call continuous delivery, which is I always have a known good code base, right? I haven't made changes that will cause problems. And so at any given time, I could deploy it, right? So continuous delivery, you might be adding the packaging, right? Maybe I take that merged together code and build in today's world, probably a Docker image or something that would be the thing that I'm going to deploy, or a jar file or a gem or whatever I'm working on.
Yeah.
And then what we do is internally, and many of our customers do with our product, is continuous deployment, which is, okay, I have a known good asset or artifact. Why is it not in production already? I mean, it's got new capability. Let's put it in a production environment and have users have access to that, right?
Yeah, that makes sense. Can you do I guess you could do like a 9 to 5 continuous deployment and then turn it off on the weekend or something like that?
Yeah, it's interesting question. I mean, we don't do that. We actually, our team is globally distributed.
Oh, that's true. Yeah.
We work much more than those hours, just because of where we are.
Yeah.
But I think ultimately, with like my history with continuous deployment, the first time when we started this marketplace in 2011, we talked about doing it, and I was like, that sounds crazy. Deploying is always a disaster. Why would I want to do more of that? But really, it's about deploying is a problem because you have 3 months worth of changes or 2 weeks worth of changes, whatever that might be. And so there's a lot of risk. There's a lot of change, and change is risk in your software environment. Ideally, you've done a great job with your testing and continuous integration, but Now I'm pushing that out. I don't know which change caused the problem. But as you break those chunks down smaller and smaller, the risk is getting broken down into smaller and smaller bits, right? So absolutely one line of code could take down your entire production site. But if you push a one line change and production goes down, you're not going to spend a lot of time thinking about what the cause was, right?
Yep.
You're just going to push the next one. You're going to fix it and repush it, or you're going to roll it back, and you're done. Right?
Yeah.
So you get to this state where basically we don't even think about deploying. It's just happening, right? And people are moving on to other things. And so the kind of fear or stress of the deployment has gone away.
Yeah,
and so
that's a really good point. There's this other part of this too, which is I don't remember where I read this, but I think it was in some game development blog. But basically, if let's say there's an issue with your login page, and that's one of 100 bugs that you have, even if people can get past the login page, it's some inconvenience. If you give this to a group of people, whether it's testers or your final audience, 99.9% of them will report that bug on the login page. They'll say, "Oh, I couldn't have an email address with an underscore in it." Or whatever it is, and none of those people that find that bug will report the next bug because they just feel like, "Oh, I'm done. I did my due diligence. Now there's 2, 3, 4 bugs, whatever. I'll either live with it or I'll move on." And so you only ever get the login bugs. There's this huge perception bias, and so as you said, as you get it smaller and smaller, you'll catch more and more things.
Yeah, that's really interesting. I mean, I think that the other thing that speaks to for me is, I do believe, even with great continuous integration, with strong test automation and good coverage and all of these things, like there's no eliminating risk, right? So ultimately, you will ship bugs into production. That will happen.
Right.
It's like everybody makes mistakes. It's a thing.
Yep. Every intern does it at least once.
That's right. That's right. Probably more.
Yeah.
And so then, you can't be relying on your users, though, to report all of the issues that they find, right? And especially if they say, "Well, I reported bugs before, this is annoying." So having really great visibility into what's happening in your production environment. We use something called Rollbar. There's others like it, which is a unhandled exception service, I guess, basically. So when an exception is thrown in our code, something unexpected happens and we aren't catching it, right? Meaning no developer thought, "Oh, this is a condition that can occur," and we know what to do. Then it reaches a top level, gets posted to another service. We get notified. And then we can say, "Oh, it's like a user is seeing a 500 error or whatever on our site," and then we can trace back. Here's the stack trace. Here are the parameters that were being passed at the time. This is the user, or this is the organization they're in, or whatever kind of information we might have.
Right.
In order to immediately say, "Oh, there's been a spike in this kind of error," or "This is a new error. Something must have gone wrong," and we can go track that down without the user having to do anything, right? And then we apply that to, metrics that seem out of line, like this rate has spiked for whatever reason, or we're seeing this new log line that we've never seen before. What's up with that? And having that kind of visibility or observability on your platform is super valuable because of that effect. Like expecting that users are going to report issues that they see is just, it's great if they do, but it's not going to happen for everything, to your point, that happens in production.
Yeah, it totally makes sense. Yeah. So, I think another really nice thing about CI that's integrated with things like GitHub is that you can guarantee that the person who wants to merge in this code has run all the tests. So you see this all the time with people who don't have CI set up, where someone says, "Hey, I have this pull request that adds this new feature." I've made this mistake myself. I say, "Sure, the feature sounds pretty cool," and then the next version doesn't work, and I'm totally not expecting that because it was contributed code that I didn't have in my mental model. And CI kind of inoculates you from that.
Right, exactly. So there's an expectation, when you put up the PR, I mean, first of all, there's a check that basically says this can't be merged because Circle CI or your CI platform hasn't returned a positive status on that, right?
Mm-hmm.
So you can, depending on the tools you use, you can make these sort of things mandatory. Like it's impossible to merge a PR that doesn't have a set of tests that have passed. Like the whole test suite having passed, not just the ones that were associated with that. The other, we can, plug in things like code coverage to that and say if the coverage has gone down significantly. We actually have gone back and forth on that because code coverage it's a whole other topic.
Yeah, I mean, it's very context sensitive, right? I mean, if you're writing a device driver or something, it might be very difficult.
Yeah. And then you can get these minor little oddities that change it to be down, and then you can't merge, but really you just added some whatever. There's many things like that. But those sorts of things to really say, okay, now and getting to the role of the code reviewer, which is a bit different in every organization, but being able to get the code reviewer to a place where they're really looking for large scale intent. Do I understand what you've done? And therefore, this feels like something that will be good for us. And like going back to future me and future other people, is it maintainable? Does it seem like there are tests that execute the kinds of conditions that I think need to be executed to really, validate what you've done, and really be thinking high level versus, as a code reviewer, if I'm expected to figure out if the logic is all correct, meaning, like I'm going to read through and parse all of the context that you had in your head, or try to reverse engineer what you had in your head, and establish with the following set of inputs, will I get the outputs I expected? That's a really hard job to ask a code reviewer to do.
Yep.
As a reviewer, I want to look at your tests, going back to why you would have tests, and say, these tests make sense as testing the input. And since you've obviously run them, then I know the output is correct given these inputs. So I have confidence in the correctness of your code. And now I'm looking at, is this long-term maintainable? Does it structurally make sense? Is it in the right place in the code base? Does this feature make sense, or does it feel like the right implementation of the product requirement? Those sorts of things, that is where a human's intelligence can be more useful.
Yeah, totally makes sense. So, okay, cool. So I think we've motivated a continuous integration for folks out there. Just one thing, continuous integration doesn't have to be for big teams or anything like that. If you look at, over the past, like over the shows, I've pointed people every now and then to projects I've worked on. All of them have Circle CI integration, and some of them I worked on by myself. They didn't really turn out to anything, but it's always kind of where you start is with that, so that you can go back and remember that future you is basically a different person, and so you're always going to have multiple perspectives on anything you write, even if you're doing it by yourself.
Yeah, absolutely. And I think earlier I was talking about larger teams just to give the context of like how did this come to be. But it's funny, I mentioned sort of not being able to imagine a world without it. And similarly, the first thing I do when I sit down to write something is like, okay, what's my testing strategy? Even for this silly little pet project or whatever, what's my testing strategy going to be? What tools are available to me depending on the language or whatever. And then how am I going to attach CI to this? And great thing, I think you were saying this before we jumped on, but with Circle CI or others like us, you can get some free build capacity for your small hobby projects and things like that. So this stuff is easy to come by. In our case, you don't have to do anything. You basically click a button, add your project, you're good to go. And then it's great. You come back in 6 months and say, oh yeah, I wanted to add this tweak or this capability, and you can jump right back in, do a little bit of work, and know that you didn't break something while you were in there because you didn't have to load the whole thing back up into your head. You have that confidence with it. So I kind of never do anything without that.
Yeah, same here. And the thing too is I've gotten better at writing tests. When I started out, I had this, when I started my career, I had this misconception that when you wrote the tests, more often than not, you would that bugs were because of some flawed assumption. And when you wrote the test, you'd write it with the flawed assumption, and you would give yourself a green light. And I'm not saying that doesn't happen, but as you get better at writing tests, that happens very rarely. So for example, if let's say you're writing a sort function, so you're expecting data to be distributed in a certain way where you want to write your own sort function that's going to be better than the generic sort, right? So, in your test, if you have some numbers and then you know what they are sorted and you make that your test, so yeah, you can maybe fall into this trap, right? Or maybe you didn't think about 3-digit numbers, like your whole trick was that it was on 2-digit, right? But another way to write this test would be to just generate oodles of numbers, sort them with your sort them with some other sort, whatever's built into C++ or whatever it is, and then make sure they're the same. And you can do that 10,000 times. And if you write a test in that way, you're much more likely to catch even a flawed assumption. And so it turns out as you get better at writing tests, you more often than not, now when I write a test, it breaks. The first time I run it.
Yeah, that totally makes sense. I mean, I think that there's some trivial things we do where, honestly, you just get good at saying, this is trivial. I'm calling one function, and that function is a system library. I'm just going to assume that it's going to give me the right result, right? And I think you kind of get stuck writing a bunch of those, and then you think, oh my gosh, it's so painful. So like everything, there's an ROI question, right? And if I'm trying to start adding tests, I'm going to say, what's the most critical piece of functionality where the code changes regularly? And I'm going to start building up tests around that, right? Or I have to go refactor this thing, or there's a bug here. That's a big place. Because if there's a bug, it's obviously not tested, right? So I write the test that demonstrates the bug. This is the place that I most commonly do effectively test-driven development. I write a test that demonstrates the bug and proves that it's there, and then fix it. And if it doesn't fix the test, then I didn't fix the bug, right? So it's a great way to take on those. And if there's a bug, then obviously that logic was harder to reason about, right? Or someone just made a typo or something, but I mean, it got out. So put that test in there, and now that you will never have a regression on that bug because now it won't pass the test, right? So and there's some interesting, just what you were talking about there reminded me of a couple things. One, some investment has been made in generative testing. Some frameworks have this where you can just say, these are my inputs, and sort of this is the transformation that I would expect for the output or whatever, and have those inputs just be generated randomly. I have a mixed relationship or mixed feelings about that because I want my testing to be deterministic.
That makes sense.
What I will do is if it generates specific cases that fail, I will memorialize those in actual, like, always run this test, right? Always run these inputs. And then maybe at the end say, and generate some random stuff, and we'll see if that finds anything else. But again, if I find those, like, I would hate for it to pass the next time because those particular values didn't get generated, right? That doesn't feel right to me.
We had this issue with I do a bunch of machine learning work, and in the beginning we didn't set the random seed. And the theory behind that was it should be robust. It should work with any random seed. And that was sort of our it's almost like became like a principle thing. Like, hey, if it didn't pass all the time, then we need to work on it. And we just gave up. We just said forget it because it's just so hard to write something when you're dealing in the realm of sort of statistics that works 100% of the time. And if you're doing good CI and it only works even 99.9% of the time, your CI will still yell at you. And so we finally said, no, forget it. Let's fix the random seed, and then we can run the test maybe 100 times in parallel.
Right. Yeah. That's actually really interesting. So the other thing that I was thinking about there, when you're talking about taking the running your sort function and running it against the original, is you can actually apply that less so in testing, but to larger scale system design. And it's a really cool pattern that we've deployed in a couple of places and I've seen other people deploy, but where you're trying to replace a system. And so you slowly run things through both, right? And make sure, and I guess this happens at very small levels in things like in like just-in-time compilers and stuff like that, where you compare two different compile paths and make sure that you got the right result. But being able to run totally different systems and then say, okay, do I consistently get the result that I got in the old system? Now I feel like this one is ready for prime time, right? Like we've deployed things in production that were just either big enough, complex enough, important enough in terms of the business that we would run them in the background and just look at the output and not tell customers that we were running because it didn't matter to them. And then say, okay, yeah, we're consistently getting the same value out of this new system. So maybe it's like faster or a different type of deployment, whatever it might be. But now we have real production level confidence that all the bizarre combinations and permutations that we see every day are going to turn out right because we've run it against the known good version.
Yeah, that makes sense. It totally makes sense. So for folks out there who, it's okay, running tests on your machine seems relatively straightforward. So let's say you're doing something in Python, you've already installed Python, you've installed a whole bunch of dependencies for Python. And so that system that's running your code can also run the tests. It seems pretty reasonable. Once you go to the cloud, I think that's where I think a lot of folks will get lost. Like how do I get that machine out there, or maybe thousands of machines out there, to have this same setup as my desktop so that I can run the same tests? Like how does Circle CI kind of work at a high level for folks who have never used it?
Yeah, well, there's actually a really great sidebar in there around using CI in general, which is eliminating effectively the worked on my machine bug, right? Because you're not deploying your laptop into production. So it is going, like, your environment needs to be able to be replicated with exactly the right dependencies and all the right versions in order to be able to support the application as you built it and tested it, right? So CI, in addition to validating your code, validates that you've effectively establish that, memorialize that, whatever word you want to use. And so if you look at many frameworks, like you mentioned Python, I'm trying to think, it depends on which package management system you use, but there's requirements.txt, right, which basically lists versions, and you can capture and fix the versions that you have in your environment. And so what you would do is spin up a CI environment. I'll go into the details of that in 1 second. Spin up a CI environment and say, pip install or whatever it is.
Yeah, that's right.
From requirements.txt, and you'll replicate that exact environment, right? So in order to speed that up, we do things like allowing you to cache your dependencies once you've created that, so you can load them back in because dependency resolution takes some time.
Right.
If you're doing it in every instance of every build that's being run, then you burn a lot of time on that. And we spend a lot of time trying to make your build as fast as possible. But effectively, it's that because the default, I'm trying not to go into the entire system of Circle CI, there's a lot to it, but the default environment that your builds will run in is a Docker container, or a set of Docker containers that you can compose together. And so you can actually build an image that's just like what you would use in production, either with those dependencies already installed, or just make sure it's exactly the right version of Python, the same thing that you're using in development and plan to use in production. Again, pass the requirements.txt or a gem file, whatever it might be, depending on the tools you're using. And then quickly reestablish that environment and then execute the tests in that environment. And then we throw it away. So other than what you can pass in and out through caches, you're basically getting a clean environment all the time. So you don't have that. I'm trying to keep using the Python example. So, .pyc file, right, where you like deleted the code, but the compiled version is still cached there. And so your code doesn't break until it gets into production. Because it was clean and doesn't have that file anymore and everything blows up.
Yeah, or you have, 10,000 Python libraries on your computer and you have no idea which ones this code base is actually using. Well, yeah, you deploy it on, let's say, Circle CI, and the tests are all going to fail. And they're going to fail
Right.
because package XYZ is missing, and you realize, oh, okay, I need that one. I don't need all 10,000 that are on my machine, but I definitely need that one. And you could kind of, at worst case, you could kind of golden line search, and just eventually get all the packages that you need in there. But yeah, starting with a clean environment is a good way to guarantee that when you run it, when someone else takes your code, that it works, or at least that that they have the bare essentials that's needed.
Yeah. And I will say I've become a big fan of virtual env or I'm trying to think of like the Ruby version that we used to use, but those sorts of things to say like, this is my project, these are the dependencies for this project, only use those, because it helps me find those problems faster. The real problems, like everyone has been through that experience of deploying something, even if they have a very simple environment, it's a single web server, you put up your little Flask app or whatever it might be, and it doesn't work. And then you sit there, scrolling through syslog or wherever this stuff is ending up, trying to figure out what it was that you didn't do.
And you're remoted into the machine. So you have this tiny terminal window, and I'm always too lazy to make it bigger because I think I know the answer. So it's like I'm looking at this tiny window and trying to run Vim through it, and it's like just this is just painful. Yeah, anything you can do on your machine to not have to do that is a good thing.
Yeah, exactly. And so trying to get you that very similar environment in Circle CI to vet those things, your dependencies, your versions, all of those other things that we don't, when we think about testing, certainly this is what we've been talking about the whole time. So myself included, we think about testing the code, right? Did I write the right logic in here? But also I want to make sure that my system is complete, right? And that I have all those pieces. And that's another thing that I'm going to, like, again, the dependencies or whatever that I'm going to capture in a CI environment before I, find out in production that I don't know. I mean, even the version of the database that I'm using, this is something that people do all the time, honestly, right? I use my Mac OS, like Homebrew or Nix or whatever, to install MySQL, but it's the latest instead of the one that we actually use in production, and they fixed a bug or added a keyword or something, and then I learned that. So, running your tests, right. like saying in your Circle CI config, I want to use MySQL 5.6.2 or whatever is actually in production. Same thing, you're going to realize, oh, you know what? I wrote something it's not compatible with the one that we use in production. I'd rather find that out now than when I've deployed.
Yeah, that makes sense. And so to give people so people might not know what a Docker image is. I'm going to try my best. It's kind of a hard thing for me to wrap my head around, but basically imagine someone gave you just a completely clean OS. So you started from scratch on, it could be Windows, Linux, whatever it is. And then they said, okay, get your app up and running. Well, you'd install the dependencies, you do all of this setup, you'd install MySQL, you'd start it, maybe you'd create the database. So there's some skeleton, some schema there, right? And they say, okay, now I'm ready to run my app, right? So what Docker does is it gives you the ability to create an image, which is basically a snapshot after you've done all that setup. And then within that, and then you can create a container, which is an instance of that image. So in other words, I have the image which says, okay, here is the blank slate with everything that I need. And in the case of, let's say, Circle CI, I might want to run 100 tests, but I don't want the 99th test to be influenced by the 98th test. So I could just create 100 containers that based on that image, and each container could run a test.
Right, exactly. So I think that's a pretty good summary.
So how do you do this? I mean, so like it must be just. Can you give us some like Fermi estimation or some like idea of the scale? It must be absolutely astonishing the number of Docker images, Docker containers, like just absolute, because anyone can run Circle CI on their project for free, and so you must have just thousands and thousands of people.
We do. Yeah. One of the things that makes Docker great for this And so, sorry, to actually answer your question before I move on to why Docker is great for this. We're running thousands of instances, the largest machines that we can get, and from various cloud providers. And then within those, we're slicing them up into many, many Docker containers, right? Mm-hmm. So as you said, like instances of Docker images. And but what makes Docker great for this in terms of like shuttling things around is a Docker image is comprised of layers. And so if you, for example, use Ubuntu 16.04, 18.04, then and someone else uses that, then we can reuse the entire operating system, right? The layer of the original Ubuntu image, and you modified it with your package, the dependencies and whatever you installed. And that when you save that, it creates a layer on top. And somebody else modifies it differently, and they get their own layer, but we can reuse the underlying layer. It's not that we do anything. I mean, this is part of the Docker technology. Mm-hmm. And so we only have to move around a lot of these small layers and bits, right? So we can cache and reuse common things. Like a lot of our customers use the same MySQL instance, right? Or the same MySQL version from the same image. And so that image will be on most of our hosts already, which makes things faster to start up and means we don't have to move as many things around the network. It's just the customizations of, in people's specific images that they move around. In fact, we provide what we call convenience images, which are optimized for our environment. So we'll take databases and we'll tune how they're accessing the file system and stuff like that to be as fast as possible in a CI environment. Because honestly, if the system crashes, it's not like you're trying to recover the data in your test, right?
Yeah, right.
So, reducing things like fsync and stuff like that to minimize overhead and allow your tests to run faster is something we spend a lot of time on because we want our customers to be able to get their job done as quickly as possible. And so because we provide these highly tuned images, more of our customers will use them, which means we also get the benefit of having that stuff, pushed out to all the machines that are running. And so it moves it, we move less stuff around the network, and and people's builds run even faster because they're accessing stuff that we've already pulled down for them.
That makes sense. So you have on the order of thousands of the largest instances. So this would be, I guess, machines with maybe like 64 cores or something like that, and oodles of RAM. I don't even know, terabyte of RAM or something.
Oodles, maybe half or less.
Half terabyte of RAM.
Yeah, so it depends on the cloud provider and whatever. Yeah.
And then one of those can handle like some number of Docker images. That actually seems so. There's a remarkable efficiency. There's definitely an economy of scale here, because I would have thought that would have been like at least 10 times as many instances.
Yeah, I mean, we pack things in, right? Mm-hmm. And so when a customer builds like any particularly complex code base, customer is generally going to build out what we call a workflow, which is comprised of multiple jobs. And the jobs can be run in parallel or in series. We basically give you the ability to define a graph, right? These are the dependencies, mm-hmm. and this is when these can run. And those actual jobs tend to be quite short. And so we're constantly, we actually use an off-the-shelf job scheduler called Nomad, which is built by HashiCorp. Okay. But it is looking in this giant pool of available resource and saying, where can I pack these in? And they're on and off machines, often in seconds, right? So if you thought about just trying to run the volume that we run and imagined it all sort of like running in parallel or whatever, yes, the orders of magnitude bigger, but because they run in short cycles and we're able to pack them in wherever we have space, which is why we use the largest machines we can get, because then you can pack it much more efficiently, right? If I've got like a 2x and a 4x and a 1x kind of thing, then I can pack those into one machine. But if I have much smaller machines, I'm like, I don't have one of those available right now, I got to wait, whatever. So we basically just make this giant blob of compute, for lack of a better word, and that gets partitioned up to push all these jobs through. So, And then it cycles over the course of days, obviously. Like our highest load is still midday Pacific time, sort of. We have customers all over the globe, but not quite as much load as we have, when Silicon Valley is doing its thing, I would say. So, we scale up and down that entire system. We rotate out old boxes so we can get patches and things in place. There's a lot happening behind the scenes that, you probably wouldn't think about, but that's what makes giving this to someone like us valuable, right? Because that's work that you would do for your own CI system if you were trying to run your own CI system. And because we don't have to have all the excess capacity for those spikes of builds that you might have as one of our customers, because one of our other customers just stopped building and we put it into that same space, right?
Yeah, that makes sense. And as you said, I think that if you're doing this yourself, you're either going to spend a ton of money and you're going to have a whole bunch of wasted resources, or you're going to inevitably fall behind. So at 4:59 p.m. when everyone's trying to catch the shuttle, you're going to end up falling, 3 hours behind on your CI. And then now, at 8 p.m., everyone has to scramble to find out how a bug got introduced, when the system finally catches up, right? And Circle CI kind of ameliorates all of that by saying we're, handling the scalability for you so you can still get the results right away.
Yeah, and I think that, whatever the time might be in your particular company, that time exists, right? Whether there's a 2 p.m. cutoff or whatever it might be, and it's like it's pretty 101 queuing theory kind of problem, right? Like if to us at such a large scale, the arrival rates look pretty consistent, right?
Yep.
But within the microcosm of a company, think month to month also, right? Like the entire kind of e-commerce sector doesn't ship a lot of code starting maybe mid-November because they're getting ready for holiday season and it's not time to introduce new stuff. Like it's locked and all we need to do now is sort of make sure we have enough capacity online and not break anything, right? As we head into the most important sales cycle of the year. And so, they're using not a lot of capacity. And then, but as in October, as everyone's trying to get everything available for that, they're using a ton of capacity. And so, it happens in the course of the day, the course of weeks, the course of months, and over the cycle of the year. We see these really large kind of differences across different sectors and stuff, but it levels out for us because we just have such a big cross section of all these companies.
Yeah, that totally makes sense. Yeah, my guess is, even then there's different products, especially different once you go to different regions of the world, different products coming out at different times, different deadlines. And so you can amortize, all of that so that you don't get these huge spikes.
It levels out. We do, regardless of all of that, we have huge customers who show up with huge, workloads at a given time or whatever. So we spend a lot of time optimizing how fast we can get capacity online. So that if we ever get caught with like a big spike and it's starting to wait, we bring machines on really quickly. We optimize the startup time of every machine, all that kind of stuff, so that we can just add that capacity. And we also keep, a free buffer pool, however you would think about pools, right?
Sure.
But yeah, definitely like the smoothing that happens at larger and larger scales is a great advantage for us.
So one thing I'm sure a lot of people are asking, we talked so many times about how it's free, and it is free. And if you're doing anything, any type of project, I highly recommend using it. I wish I used it on my PhD. I don't think Circle CI was around when I was doing my PhD, but learned a lot of lessons the hard way. So definitely jump in there. But then the obvious question is, how do you make money, right? If everything is free. And so what's sort of the pricing and what is like how does Circle CI work as sort of a business?
Yeah, so we actually making money is not a problem for us, I guess is the short answer to that. But
sure.
But so we have a usage-based pricing model, which is actually a change for us over the course of the company. It used to be you bought a certain amount of capacity. Sort of think about how you buy bandwidth for your house. It was like whether you're using or not, you have this much capacity, and if you hit the limit of that capacity, then you wait. And that was simple and people understood it. It was good from that perspective, and you have predictability. But as we've grown and as our customers have grown, suddenly they say, well, we have hundreds of engineers working. We can't make people wait. How do we manage for that? So we shifted to a usage-based pricing model. And so for free, we basically give you a limited number of minutes per month sort of thing if you're a free project or a small user. We do more for open source projects. As a means of giving back to that community. We use lots of open source. We try to contribute back to the code, but also want to support the open source community. So we give them more capacity.
Got it. That explains why, because I have several projects. I've never hit any limit. And I think, as you said, they're all open source projects.
Yeah. And I mean, the majority of those, honestly, like the majority of open source projects just don't build that much.
Yeah, that's true too.
It's like a little library. Someone comes along and puts up a patch, but then we have open source projects. So PyTorch actually builds on Circle CI and is a very large open source project. A lot of contributors. It's running a lot, and we can't just give that kind of capacity away for free.
Yep, that makes sense.
But then in the I would say in the middle, but we have a lot of commercial customers, right? We have customers whose entire engineering org of 1,000 engineers or whatever is built on Circle CI all day, every day, and so they're well over the free limit.
So how does that work? So they, I guess the code is still safe in a sense. So those folks, it's not through GitHub, or maybe it's still through GitHub, but it's a private.
It is through GitHub.
Oh, yeah. I see, but it's a private repository, and so their Docker image goes to you, but it doesn't. No one else can see it, and then you run their tests, and then
Right, exactly. I mean, we have isolation between all these parts of the system that I was describing, and we wipe everything out in between builds and isolate networks, and I mean, we do a lot of things
that makes sense.
To build a multi-tenancy system where we can have this kind of packing and get the efficiency without the security risks, right? So, it'll be their private GitHub account, and all of their users have GitHub users within their GitHub org, and then we're pulling from that, pulling the code down, finding the images that they want to use. Same process, but we do that for very, very large organizations. I mean, we have a broad spectrum of organizations, from kind of the 2-3 people in a garage, or where WeWork, I guess, is probably where they are now. But
yeah, that's right. Maybe, I don't know what's going to happen at WeWork, but we'll see.
So that landscape has changed. The garage was always the joke although I've never actually worked out of a garage, but So you've got 2-3 people, but if they're building constantly, then they're starting to move into the paid plan, but their usage will be low.
Yep, makes sense.
Again, we have public companies, using our platform, and so really, really large engineering teams, many, many different teams within the engineering organization. Doing mobile, we have Linux and Windows and iOS or Mac OS, so they can be doing a multitude of things. And that's just all coming out of that same capacity pool in terms of their credits, right? So they basically sign up for credits and then use them to support your usage.
Got it. If someone isn't using GitHub, can they still use Circle CI? What does that look like?
Yeah, so we have support for Bitbucket, and we're adding some others at the moment. Mm-hmm. And so, I mean, GitHub has been certainly for cloud-based version control, has been the dominant player for a long time, but the market is shifting, right?
Yeah, right.
See a lot more people. We had seen people going to Bitbucket for a while. We see people moving to GitLab or starting out on GitLab. So yeah, we basically support multiple.
So yeah, I think the challenge with GitLab is you can host your own GitLab, and so. How would that work? So someone's hosting their own GitLab. Can they still use the Circle CI plugins? Is that a thing?
Yeah. So, there's a couple things. One, we do actually have a behind the firewall solution, or we call it server. So you can take Circle CI and run it yourself. Of course, you lose some of the things I was talking about.
That makes
everything
sense.
that we do to manage the scale and different types of compute types and those sorts of things. But for large organizations that have, dedicated teams to run this kind of thing, and maybe have, they have their source control behind the firewall also and want to work in that way. So we do that for GitHub Enterprise. And then for GitLab, which we're working on now, it will be sort of a, I don't really know how to describe, but basically a conduit back to our cloud from the server side.
Yeah, that makes sense.
You have GitLab installed, ultimately our customers tend to be coming to us looking for not just great CI, like in terms of the developer experience and how you do config and all those sorts of things, but also us managing it. Because that's another big step in the value that we can provide and work that we can take on so that they can focus on, building their product.
Yeah, that makes sense. So, this is amazing. Yeah. So just to wrap up the Circle CI a little bit, then I want to jump to some other questions. Everyone should use Circle CI. So everyone out there, try it out. Hopefully you're using GitHub or GitLab or Bitbucket, one of these source control for your personal project. But if you're in high school, if you're in college, check this out. It's going to be really useful. I've gotten to the point in some projects where it was a good idea, but without any tests, it just got too hard. I mean, at one point I was making this video game. This was in high school. And it was a hockey game. I'm also from Toronto, so I'm a big hockey fan. And I was making this hockey game, and there was a bug, and I had to play the hockey game to the third period to see the bug. And I did this like 4 times, and I couldn't figure out the bug. It took about an hour or I don't know, maybe 20 minutes each time. So I just said forget it, and I stopped working on the project. Right? And don't be like me. Don't put yourself in a corner that way. If you already have projects like that, you can save them, you can rescue them with good tests. I actually wanted to ask you about what is, the sort of interview process like. So if someone is, just so first of all, are you hiring, software engineers, data scientists, those kind of folks?
Yeah, absolutely. Both.
Yeah.
So we have a large, my engineering organization is about 90 people and continuing to grow. So we're always looking for, for people in various roles within engineering. Mm-hmm. And then data science sits outside of my team. Although within my organization, we have some folks working on data from a product perspective. So as you're using Circle CI, right, understanding how fast are my builds running? What are the trends? Are there specific, flaky tests, or are there tests that are constantly failing that maybe we need to go work on? Like providing that kind of insight to our customers. So we have folks working on that. But then from a data science and analytics perspective, we also do work around, our business, how our business is functioning. And then from a product perspective, how are people using this? Are they getting what they need? What can we do? How can we change the way that our application works to provide them, a better experience that will help them do what they're trying to do better, right? So we take advantage of the data that we have. I mean, we've been running this system for 8+ years. We have hundreds of thousands of projects building every day. I mean, we have a lot of data. Is basically what I would say. So yeah, we're constantly looking for help across that whole spectrum.
Cool. So what's an interview like? So someone shows up straight out of college, shows up to Circle CI headquarters. What's the day going to look like for them?
Well, interestingly, to start on that, we are actually distributed fairly globally in terms of our engineering team. So we tend to do a lot of interviewing remotely. We spend time, talking to each other on video. The process, effectively there's a screen of some kind, like any other, you submit your application or, give us your resume and tell us a little bit about why you're interested in working with us. And then you would probably meet a hiring manager, who would ask you some high level questions about, your focus, things that you've done. And then we do a coding challenge. This is an interesting thing, I think, in the industry that we've all gone around in different directions on. But ours is it's a homework assignment, effectively, or take home. And we try to get you to time box it to 2 hours. And you spend some time working on that problem. And the goal is that you can then come have a conversation with us about what you did. Because we've tried in the past doing live coding, like I'll sit here and stare at you on video while you type.
Yeah, right. That's painful.
It's brutal. It's the process that I went through as we joined Circle CI because they wanted to vet us as engineers.
Yep.
And I was like, I swear I know how to write software, but I cannot in this moment remember how to write code because there's someone staring at me, and it's just it's not how software gets written.
And the editor doesn't give you any flexibility, right? I mean, it's like trying to run on concrete. There's no tab completion, there's nothing.
Yeah. Oh well. In this case, we would screen share. So you would use your.
Oh, that's actually good.
Which is a more comfortable situation.
Yeah.
It's certainly better than trying to write code on a whiteboard, I think.
Yeah. Right.
I will say one of the places that I always do test-driven development is in a coding interview. Because someone will say, this is what I expect. And I'll be like, okay, so if this test passes, then I have done the right thing. It's a great way to validate that your understanding of requirements.
Yeah.
But anyway, we don't do that anymore. But we do ask you to take home, or, to take this thing that has some written code and you're going to work on it. And then come back and have a conversation. What did you think of it? How did you make these decisions? What would you do next? Those sorts of things. Because it's a much more comfortable environment. You've taken some time to think about it. And honestly, most engineers that I know like to have some time to reflect on things and sort of digest them, right? It's in the moment. It's not often the best for software developers. Like in the moment, this kind of like quick banter about stuff.
Yeah,
right?
especially when you're an expert. The person asking the question has asked it 100 times. And then it can be so hard to be positive when the person's just kind of like, yep, because they've just been through it so many times, right? And it's easy to feel like, wow, everyone at this company knows bubble sort so well. I'm so intimidated, right? But the reality is they've asked that question 1,000 times, right? And so, interviewing is a big challenge. So I actually love this idea of sort of this homework assignment, and then you can have just like a more Socratic discussion, right?
Right, exactly. Like you've had some time to think about it. It's closer to the real world. Like tell me what your experience was, and then we sort of talk through it and ask some specific questions. Maybe ask some questions about choices you made or like whatever. So I'm not gonna give you too much detail because we still use the same process.
Oh, sure. No spoilers.
And then we have another sort of more higher level system design level or system design oriented discussion. Mm-hmm. And in that case, we sort of talk you through what we're looking for, and you would talk to us about how you would design the system in certain ways to meet those requirements. And then we do a more product-oriented conversation, which is usually more based off of your experience. And so this is interesting because you're talking about kind of new grads, and we adapted a little bit for that. But you just talked about building a game in high school. Like new grads from college, I'll say these days because I'm that old guy. Like I had not built a game by the time I graduated from college. Like I basically knew a tiny little bit about software development, right? So talk about things that you've done, but usually again focused on either interactions with a product management group if you've had that experience, or how you think about the customer and break down the problem and stuff like that, right? So a little bit outside of the kind of CS fundamentals perspective, and more into like real work as a software engineer, right? As a software engineer, I'm not, as much as we like to ask questions about, well, we don't ask a lot of questions about bubble sort, but like we don't all spend our days writing bubble sort over and over, right?
That's right.
We're trying to solve customer problems. We're trying to help them, have a great experience on our platform. And we're trying to prioritize with a limited number, like a limited team, all of the things that we could go pursue and really drive maximum value for the business and for the customer, right? And so that's a big part of what we do every day. And so really having a conversation about that and kind of understanding how people think about those sorts of scenarios, how they think about breaking down work and validating things. And of course, we live in this iterative, agile world. kind of experiences with that.
Yeah, that makes sense. And people could do a lot of this in college. I think that if you work on a team, so if you have a senior design project, you're going to have to coordinate, and you're going to deal with a lot of these issues. And I think one piece of advice we give a lot of folks is just build stuff. As you build things, you're going to realize, we talked about tests, but you'll realize a lot of different, you'll have to sort of plan your time. You'll have things that other people want from the thing you built that you might not be able to fulfill, right? And so you have to prioritize that. And these are all really good experiences that anyone could have right now.
Yeah.
So you said you're distributed. So that means that if someone is in, I don't know, London, they stay in London. Like how does that whole thing work? Is there a lot of communication on Slack? Like, what's a distributed company like?
Yeah. So we have specific countries at this point where we're incorporated or have entities. And so that includes Japan, UK, Ireland, Germany, Canada, and the US. Mm-hmm. And yes, so most of the people outside of San Francisco. So our headquarters is in San Francisco, mm-hmm. But there's actually a very small portion of the engineering team in San Francisco, like marketing, finance, revenue. We have a bunch of people in San Francisco. So mostly people are working from home, kind of in these different areas. We do have an office in Toronto, actually.
Cool.
And Zoom. We use a lot of Zoom, a lot of Slack. We try to organize ourselves in a way that the time zones are not too challenging, but it depends. Different teams have different.
Yeah, that is a
situations.
Very hard problem, right? I mean, because you have, in your case, you mentioned Japan, and then you have London. That's what, 12 mm-hmm. hours or something, right?
Yeah. So actually that kind of ends up being 8. How does it work? Sort of like Tokyo to San Francisco is about 8 hours.
Oh, okay.
San Francisco to London or Dublin is about 8 hours.
Yeah.
So if you try to make a meeting with people in those three places,
right,
somebody has a terrible time.
Yeah.
So we try not to have, one team that spans, all three. I think we have one that's got, too many time zones right now.
Yeah.
It always happens, but we try to organize ourselves. And as we continue to grow, it becomes easier to say, we'll just build this whole team in Europe, or we'll build this whole team in West Coast North America plus Tokyo or something like that, right? When you're smaller and you just have one expert or two experts in this thing and they happen to be in different time zones, you're like, well, you're on the same team now, So it can be a challenge, but yeah, a lot of we try to do as much async as we can. It can be challenging. It can create some overhead, but it creates some positives, right? Like, I think there's things that we end up doing when we're all co-located that we would break the habit as we're distributed, like documenting things effectively.
Oh, that's a good point.
Our decisions are, where it sort of forces practices that are actually good practices, even if you're all together. And actually, my favorite thing to call out that's a great practice. And, people say, how do you know that people are getting, are doing their job, right, in a distributed team? And when someone asks me that, it makes me think that when you're centrally located asking me that question, your approach to are you doing your job is, are you in your seat from 9 to 5?
Yep.
Right. But I can't tell if anyone's in their seat. Like, you might be at home, or you might be in a coffee shop, or you might actually be in another country right now. It's hard for me to know. So what am I going to measure? What am I going to think about? And I'm like, there are a couple layers of management between me and sort of individual engineers or whatever. But we talk about results. Like, are we having the impact that we said we were going to have as a team over the course of this period? And if we did that, then we're probably doing our jobs effectively. And if we didn't, most likely some other thing is causing problems, right? But if it becomes clear that someone is just not producing, then, a manager's going to have a conversation with that person and say, hey, like, what's up? Seems like maybe you're having some challenges. Do you not have the information you need? Do you need someone to pair with you? Like, there's a lot of things that could be going wrong. We know we don't jump straight to like this person or whatever. But I think when we're co-located, we have this crutch of like, people are here and they seem busy. So probably.
Yeah, that's fascinating. I think I think there's this sort of dual problem, which is if you're not co-located, someone might not work a lot of hours and they might not be around, actually working a lot, but then they could get their job done. So potentially maybe there's somebody, especially if you're paying salary, there's someone who, for whatever reason, they're getting some unit of work done, but they're not taking that much time. But actually, that's not a big deal. The big deal is the reverse, where someone's spending a ton of time and they're actually not getting that much done. And so I think that, to your point, the crutch actually can end really badly, where somebody is just always in the office. And often this is because they've sort of misscoped the problem. So they haven't managed up very well. And there's this problem. It's actually extremely difficult, but because of the way it's been communicated, it sounds like it should be pretty easy. And then this person spends an extraordinary amount of time and then still doesn't perform well. Versus if you're remote, that the time isn't being watched. And so if you're not if you're not completing this work package, you're going to pretty early on go and tell your boss, hey, this is actually really hard. And, I'm spending a ton of time on this. I'm not getting it done. If you have the crutch, you might just assume your boss is seeing you there. And most companies don't, at the end of the day, what's going to matter is that work package done.
Right.
Yeah.
Or, well, I mean, we also spend a lot of time trying to translate that into impact, right? Because there's kind of two things that happen there. One, I've taken on a thing that felt like it would be easy. It's actually really hard. And that can be challenging remote, because if you're not comfortable raising your hand, then you're even less comfortable like shouting into Slack or whatever, hey, I don't know what I'm doing. Can someone please help me? Which you should totally be comfortable doing that, but people struggle with that. And the other though is you take on work, which actually turns out to be hard, assuming, because you've made this connection at some point, with your product team or whatever, this work is going to drive this impact. And if it turns out as you get through it that the work is not driving the impact the way that you expected, where impact would be, more users signing up, people having a better time on the platform, they're engaging with something, whatever, you should stop. You should at least stop and have a conversation and say, hey, we set out to do this thinking it was going to do this for our users or drive this value for the business, and it doesn't seem to be doing that. So, let's not just keep charging down this path. Let's make sure we're checking in at least and saying, hey, did we misread something? Are we just too early? Is the signal delayed? How do we feel? Should we continue to invest, or should we take on something else? And I think as you orient more around the value you're trying to deliver, and you surface those conversations, then it's easier to make sure that that folks are all engaged and they're succeeding and whatever, and B, it's just better for your business, honestly.
Yeah, that makes sense. So I have this theory, and the theory might not hold water, but let's assume it doesn't go from there. I have this theory that once you hit 200 engineers, that you inevitably end up with warring factions, and you can't stop it. Like, you just hit some critical mass, and what happens is there ends up being this sort of fragmented identity. So for example, you hit this large enough org, and now the researchers and the engineers aren't getting along. Maybe the engineers who are doing more on the research side and the more applied engineers have split up. And it's not obviously in the org chart. I mean, the leaders don't necessarily want that to happen, but it's an organic thing that once you get to this size, it seems hard to have a common identity. You don't really see the existential threat, or the existential, I guess threat, for lack of a better word, and the internal threat starts to sort of reach parity, right? And so Circle CI is at, I think you said 90 engineers.
Yeah.
So you're halfway there. So, but you can kind of forecast like how do you deal with this where, maybe a team says, has a really strong team identity, but then that team always seems to be battling with other teams, right? How do you sort of, balance that against sort of another team that maybe doesn't have a strong identity, and then they can't really execute and retain talent, right? That's how do you sort of strike that balance?
Yeah, it's a really interesting question. I mean, I think you kind of, I'm going to take your lead on something you said in there, which is the existential threat being replaced by an internal threat, right? And I think threats or not, your greatest hope of alignment is clear top level vision. And I'm not saying that we're amazing at this. Like, this is something that I'm constantly spending my time thinking about and trying to help be clearer about. Mm-hmm. And when people in multiple teams all see the same direction and buy into that direction, I think that does a lot to tamp down that kind of, I'll call it infighting, or whatever you're describing. In that, when you get to this place where you feel like your reason for being is your team as opposed to the company, then that's where that starts, right? So you think, okay, we really want to do this thing, and that's important to us, and therefore we're going to do it, and we're going to do it, to the detriment of this other team or whatever. Whereas when you feel like we're really driving towards this bigger goal together, then you look at this other team and say, hey, we kind of need a thing, you need a thing. Like, how can we work together to figure out the best outcome for all of us, right? And I think that there's a couple things in there. The top level vision, direction, people being aligned around that is really, really critical. But then that has to happen down through layers of management, right? So, I mean, at some point, though, to your point of the org chart, at some point those two teams fall under the same person, right? And it might be all the way up at the CEO, but quite likely it's, a manager, like an engineering manager or a director or something like that, right? And that person should have clarity about their mission, right? Okay, if this is the mission of the company, this is our mission, right? This is what we're doing that supports that. And being able to connect those dots is really important for people, right? Like feeling like I work on a thing day to day and I don't know why it's related. And we see this, but I don't know why it's related to the overall goal of the company is really bad. That's not a fun feeling, right? When you talk about retaining talent, feeling like you don't know what the value that you bring, or you don't know the value that you bring to the company it's not a fun feeling, right? So being able to connect that, and then being driven by honestly a smaller mission that aligns with the bigger mission, that's easier to connect to your day-to-day work, right? So, for example, like I talked a bunch about how much we care about the speed of builds running, right? And so ultimately, our customers are happier when their stuff runs well, runs quickly on our system, and they can get their job done, right? And so we get more customers as a company, we're more successful. But if I work on a team that, provisions hardware, not that the team provisions hardware, but builds tools that scales our fleets up and down, then I can directly connect, my ability to make sure there's capacity online, countered against the money that we spend, with customers' happiness, right? And so I see like impact on the top level kind of company and customer based on how I'm able to do my job really effectively. And so rallying around that, I mean, it's kind of a contrived example, but rallying around that allows me and probably a few other teams around me, right? Maybe I need some people who know more about our operational deployments. Maybe I need some people who've built some upstream code or whatever. Like when we see that shared goal, then we can work on it together instead of being about like my team, right?
Yeah, that makes sense. So what about when you have sort of things that are more zero sum? So for example, there's a team that's trying to reduce the compute, reduce the bottom line, right? So to not take such a hit on compute. There's another team that's trying to make people happier by giving them quicker builds, but that costs money. And so I guess that's one of those things where I guess you have to try to turn that zero sum into a positive sum where everyone can kind of come out ahead.
Yeah, I think it's really interesting. I mean, we probably have like another hour and a half on organizational design or whatever, but that's like it's a really interesting problem where like I wouldn't want to end up in a situation where one team is responsible for cost and another is responsible for like the that customer happiness, but rather those are themes that we understand at a top level and then down through the org. And then my team, let's say in this case I'm describing, is responsible for, job allocation and job execution, right? And so I don't worry about user interfaces and how config gets written and other stuff, but I worry about once we know something needs to get run, we're going to get it run as quickly as possible. And I am optimizing performance and cost against each other, right?
Yeah,
and so
that makes sense.
I own a domain or whatever, and I know these are big parameters for the company. And so I can reason about how to balance these things. If someone else owns
that totally makes sense.
And I own job allocation, like we're going to have a really sad time. Like
that's right.
It's like I was joking about this earlier, but like this classic comic of, two people digging ditches behind each other and they're like dumping another hole, right? Like just basically making each other's lives miserable and running in place. And so like it's one of the things that you try to think about in structuring kind of both goals and teams, is being able to align that big picture without, partitioning them in that way.
Yeah, that totally makes sense. Yeah, I think, if you can take those zero sum situations like machines versus people's happiness and basically break them down so that every team has the zero sum, then yeah, they're not in this position. Yeah, that's a really great answer. I appreciate it. That's something that I was kind of been mulling about, so it was great to get your take on it. Cool. So how can people reach you if people want to apply to Circle CI? How can they do that? What are the best ways to reach out?
circleci.com/jobs is, everything that we have currently open. To reach me, I'm on Twitter at Zoob, with Z00B.
Oh, nice.
You have to spell it, but
yeah, cool.
I've been dragging that around for a while.
That's awesome.
Yeah, or I don't know. I mean, I'm out there somewhere.
Cool.
Some conference or something like that.
Oh,
I'm not
yeah,
that hard to track down. LinkedIn, I guess, if people are interested.
Cool.
Although Twitter's probably easier if you don't know me, because I don't.
Yeah, they could just
don't
add
necessarily respond to everything on LinkedIn.
Yeah, totally makes sense. So circleci.com/jobs. And I didn't ask this, but do you have internships or just full time?
Currently just full time.
Okay.
It's something that we are trying to figure out how we can do better. It is one of the challenges of remote. We do have, like I said, we have an office in San Francisco and one in Toronto, but they're not particularly large. And so for internships, we always want to make sure that someone's going to have a great experience, have a lot of support around them.
Yeah, that makes sense.
And so like, hey, be our intern, but just sit in your living room and like ping people on Slack.
Yeah, right.
It's not the experience I would sign up for.
Yep.
Personally. So we're trying to figure out how to get there.
Yeah, totally.
Doing that at the moment.
Cool. Well, Rob, thank you so much for coming on the show. I would ask for if you had student discounts, but it's totally free for students, unless your project reaches PyTorch level popularity, in which case you should reach out to some venture capitalists or something like that.
Yeah, right. By that point, you probably need a discount. So
Yeah, exactly. So thank you so much for coming on the show. And if folks have questions, they know how to reach you, and I really appreciate it.
Awesome. Thanks for having me. It was tons of fun.
The intro music is Axo by Binar Pilot. Programming Throwdown is distributed under a Creative Commons Attribution Share-alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.